Hello friends, welcome back to our channel. So today we'll discuss about one more concept in R programming, that is built-in data structures. So in R programming we are having a lot of data structures, built-in data structures. Among them, the first one is a vector. So this is a single dimension, and this is a homogeneous data. It's a collection of homogeneous data. That means it will having the elements of same data type. And the syntax for vector is some variable name, or we can say it as a vector name, is equal to C of element 1, element 2 and so on. So here all the elements should be of same data type. So either it can be integer, or it can be a float, or it can be a string or character data types, right? So this is syntax for creating the vector data structure. And the second one is a list. So list data structure is also similar to the vector, and it is also a single dimension. It's also a single dimension, but it is nothing but a collection of heterogeneous. That means it is a collection of elements, multiple elements of different data types. So we can store all the elements of different data types. So that's the main difference over list and vector. And here the syntax for creating a list is variable name, or we can call it as a list name, right? Variable name or list name is equal to use a list function followed by element 1, element 2 and so on. So here the elements can be of different data type. So here elements should be of same data type, right? That's why we are calling it as a homogeneous data, and here it can be of different data type. So no need to worry about all these things. I'll implement each and everything in the RStudio. So we'll execute a small program. Just we'll create a vector and we'll print the vector. We'll create a list and we'll print the list. Okay. For all the data structures, I'll show you the implementation. So don't worry about this. So just we'll see the syntax part. Now the two things completed. Then third data structure is a data frame. Third data structure is a data frame. So a data frame is a tabular data representing data in tabular format. So it forms a table, right? So it can be a collection of vectors. So for this we have to use a function called data.frame function. Right? So example, here I'll give you an example. Let us take some vector 1. See, v1 is equal to C of some element 1, element 2 and so on, and vector 2 C of element 1, element 2 and so on. And now you can go with the data frame is equal to data.frame function, and pass on these vectors v1 comma v2. So obviously if you execute the program, you will get the data in a tabular format, like giving a names as v1, v2 and indexes as 1, 2 and so on. So you get element 1 and element 2 and so on, and here also we'll get element 1, element 2 and so on, right? So in this format the output will be displayed. That means that it will represent the complete data in a tabular format. So that is the data frame, data structure, data frame. Then the next one is an array. So array is a n-dimensional representation. We can represent the data in an n dimension, and here we'll give some order of data. Let it be some 2 by 2, 2 by 3, 3 by 2, right? Like that. So here it will accept, we have to use an array function to create an array. Array function to create an array. Right? And the syntax for this array is some variable name or array name. Okay, variable name or array name. Give the array, give the vector here, the complete vector, and the second parameter will be the dimension. So the dimension should also be given as a vector in terms of vector, right? So for that I have to give the dim parameter, a parameter name called as a dim, which is called as a dimension. So dimension is equal to vector. So it consists of three things. One is rows, columns and number of arrays. Rows, columns and number of arrays. So if this dimension is C of 2, 2, 2, that means whatever the vector here we are giving, so this is completely data. The vector is a data, right? So this data will be arranged in a 2 by 2 array of 2 arrays. So this is a rows, columns and this is a number of arrays, right? So 2 arrays with the order 2 by 2 will be created. And if you are giving here 3, that implies 3 arrays with the order 2 by 2 will be created, right? So the first one row, column and number of arrays with particular dimension, right? So these two are the parameters we need to give for array function in order to create an array. And the next one and the last one is a matrix. See, matrix. So matrix also will create in terms of rows and columns, right? So we'll represent a matrix order as a rows, number of rows into number of columns. So here also the same thing. So this is also rows and columns. The data will be represented in rows and columns, right? So here we need to give the n row and n column, right? N row means number of rows, n column means number of columns. And also the third parameter is an optional. It is a row wise, right? So by default it will be the column wise, right? So here I'll write a default, it is column wise. That means whatever the elements we are giving, that will be arranged in a column wise. So if you are using the third parameter as row wise, third parameter, so we can use a row wise. We can arrange the elements in a row wise. So here we will use a matrix function to create a matrix function, right? Now I'll write the syntax here. So variable name or matrix name. So we can write anything is equal to, use a matrix function, write down the vector. So vector is nothing but a data. So complete data should be written as a vector here. Vector n row, n column, and the third one by row is equal to true. By row is equal to true. So capital letters, right? Boolean data type, it's a capital letters, true. So this is a vector, this is a complete data we need to fill in a matrix, and this is a number of rows we require, and this is a number of columns, and this is a row wise ordering. So this is an optional thing, this is an optional parameter. So in the absence of this by row parameter, the data will be arranged in a column wise. Okay, for example, consider a vector some 10, 20, 30 and 40, and if you want to give number of rows, n row is equal to 2, n col is equal to 2, that means 2 rows and 2 columns. So first the arrangement will be done in a column wise, right? See, so 10, 20, 30 and 40. So the arrangement will be done in this way. And if you add one more parameter, this by row is equal to true, right? Now the elements will be arranged in a row wise. Row wise means 10, 20, 30 and 40. The elements will be arranged in this order. So that is the importance of the last parameter by row. So this is an optional parameter. So in the absence, data will be arranged in a column wise. In the presence, data will be arranged in a row wise, right? So this is all about our matrix. So we have seen a different data structures: a vector, list, data frame, array and a matrix. So all these are available in our R programming. Now we'll move on to the RStudio. So I'll show you the implementation and the syntaxes of all these data structures. So let us move on to the system.
So hello friends, so just now we have seen the theoretical part of different data structures in R programming. So we have seen the syntaxes. Now we'll see the implementation part, so how we can implement these data structures, the complete basic thing. So in depth we'll go in our further concepts, right? Now let us open the RStudio environment. So once it was open, so we'll go one by one. So starting from the vector, followed by a list, a matrix, array and a data frame, right? So let us write a small, initialize a vector here. So some v is equal to c of, let us give the values, so 10, 20, 30, 40, 50, and let us print that particular vector here. So execute the complete statements. So go here, so execute, you can get the elements here, right? So this is an environment variable. So here indexes 1:5 and the values will be printed in this particular output console. Now let us try with the different data types and execute. See, it was accepted. So we have studied that a vector is a single dimensional part, so where it can accept multiple elements of same data type or not a different data type, because you can observe here. So whenever you given 9.5, you can see every element have been converted into a float. So unless there is a 9.5 here, so it was executed, but all the elements are in of integers, right? So here it will accept the homogeneous elements, that means the same data type. Now we'll move on to the next one, that is a list. So let us change L is equal to, in order to create a list we need to apply the list function. So list function and give the elements, and it is nothing but it's also a single dimension, but the elements can be of different data types. It will accept different data types. So if you give the same thing, see, if you give the same elements, that means some 5 elements of integers and one a float, and I'll print L, and now you can observe, see, the 5 elements are of integer only and the last element will be the float value. So all the elements will be remain same. That means it will accept the heterogeneous data types. That means a multiple data type elements, right? So vector is a single dimension and a list is also a single dimension, but the main difference over a vector and a list is, in a vector it will accept only a same data type of elements, and in a list it will accept a multiple data type of elements, right? Now we'll move on with the next one, that is a data frame. So let us create 3 vectors. So data frame is a tabular representation, just now we have seen, right? So in order to represent any data in a tabular format, so we can go with this particular data frame, and here we can give multiple vectors and we can collaborate all those vectors into a data frame so that the data will be displayed in a tabular format. So let us take some student details. Let us take some S number is equal to C of some 101, 102, 103, and so these are vectors, right? These are vectors. So student name is equal to C of you can give ABC, DEF, GHI. So all are of same data type because this is a vector and it will accept only the homogeneous data. That means every element should be of same data type. And I'll go with the percentage. Student percentage is equal to C of let us give some 98, 89 and some 80, right? Now we will combine all these vectors in a data frame so the complete data will be available in a tabular format. Let us take, so df is equal to, the function is data dot frame, and you can pass all these things: s number, s name, sorry, s number, no I think we have given, so s name and s percentage, right? Now you can just print data frame df. So if you execute here, you can see s number, s name and s percentage, and you got the complete details in a tabular format. So 101 is a serial number, and serial student number is 101, student name ABC, and student percentage 98. So here we have given an individual vectors, but in the output we are seeing the tabular format. So in order to represent any data in a tabular format, we can go with the data frame, right? And the next one is an array. So we know that array is also homogeneous elements. Okay, so here we use an array function to create an array. So A is equal to array of, so give a vector C of, I'll give some 10, 20, 30, 40, 50, 60, and in array we need to specify the dimensions. So array can be of n dimensions, right? So it will be having a 2 by 2 array, 2 by 3 array. So dimensions means 2 by 2, that means 2 rows and 2 columns. We call them as a dimensions, right? So here we need to give a second parameter dim and give the dimensions as a vector. So in the dimensions, 3 parameters. The first one represents the rows, second one represents the columns, and the third one represents number of arrays of the particular dimensions. So here we have given some 6 elements. I'll give some 2, 3 and 1. So that implies the dimension is 2 by 3 matrix. The order of a the array is a 2 by 3 array of one array, right? It will be having only one array. And now we can see print A and execute. So you will be getting the same thing. See 10, 20, 30, 40, 50, 60. So everything will be in a column order, right? So you can observe the 2 rows and 3 columns. 2 rows and 3 columns. And the same thing, we can give a matrix. We can give a matrix. So m is equal to, we need to give the matrix function. So in that matrix, again, you need to take the complete values. So C of 10, 20, 30, 40, 50, 60, and here we need to give the number of rows and number of columns. So order of a matrix, right? So n row is equal to, I'll give it 3 rows, and n column is equal to, I'll give it 2 columns, right? And simply print m, and you can observe here, see the 3 rows and the 2 columns. So if it is an array, we need to specify the dimension. So here, there also we need to specify the number of rows and columns, but we call it as a dimension. And coming to the matrix, here we need to give some n rows and n columns, and you can observe by default it will be taking the elements as a column wise. If you want to arrange them in a row wise, so you need to add one more parameter called by row is equal to true. So elements will be arranged in a row wise. So you can observe here 10, 20, 30, 40, 50, 60. So if you are not giving this by row parameter, so the data was filled with a column wise. See, 10, 20 is in second column, I mean first column, and 30 will also be in the first column. Then only 40, 50, 60 will be arranged in second column. Now if you add this parameter by row is equal to true, and if you execute, you can observe 10 and 20 will be the first row, 30 and 40 will be the second row, and 50 and 60 will be the another row. So that means the elements will be arranged in a row order. So we'll change the data types. So 30.4, 40.5, and still execute the same thing. And you can observe this is a homogeneous. Everything has been changed to float. Everything has been changed to float, right? So a slight difference among the vector and a list as well as an array and a matrix, right? So hope you understood. These are the basic data structures, and we call them as a built-in data structures in R programming. So we can make use of all these type of data structures according to our programs, right? So hope you understood. And if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.